Good afternoon, everyone. So we move on to the next topic, the index of soil properties 2. No. So we'll tackle this time the mass volume relationships, consistency of soils, the Atterberg's limits, soil structure and particle shape, mechanical analysis of soil. But for this lecture video, will not finish all this topic outline. No, we might tackle only the mass volume relationships and this Atterberg's limit. For the intended learning outcomes, the student should understood the relationships of different index soil properties of soil, calculated the different index properties of the soil, generated the flow curve, and determined the LL, or this is the liquid limit, the PL plastic limit, and the plasticity index. Discuss the different types of soil structure and particle shape, then generated the particle size distribution curve, and calculated the this is the coefficient, no, the C sub U and the C sub C for the settlement. So we'll discuss this one later sa atong topic. We have this mass volume relations. So we have three phases of soils, the solid, liquid, and the air. The solid means the soil particle, the liquid, which is the water electrolytes, and of course the air. As you can see, there is this figure or an image of a soil, and if you try to understand its composition, there is this S, this is the solid or the soil particles. Then we have these voids or the gap, which is the water, and also there is an portion of A, which is the air. So if you try to make that one into a face, a face, you will have this at the bottom portion is the soil, then we have the water, and the top is the air. So we denote the V sub S as the volume of soil, the V sub W as the volume of the water, and the V sub A as the air. These, if you try to notice, there is this V sub V. This is actually the volume of the voids. The voids compose of the volume of the water and the air. While this V sub T, this is the total volume, which is the that includes the volume of the soil, the water, and the air. In terms of mass, we have this M sub S. This is the mass of the soil. The M sub W is the mass of the water. And the mass of the air is almost approximately equal to 0 or negligible. No? So that the total mass is only the mass of the soil and the mass of the water. We have this annotation also, rho sub S, this is the density of the soil, rho sub W, density of water, and the rho sub A, this density of the air. So we still have this weight volume relationships. Actually, this is the same with the figure, no, earlier kanisha. Then we proceed to, yes, the total volume is, this is V sub T. We try to correct this one. Say black one. Okay. So this is V sub T. Where the V sub A is the volume of the soil solids, no? V sub B is the volume of the voids. V sub W, the volume of the water and the voids, and V sub A, the volume of air in the voids. So the total weight is WT is equal to W soil plus W water. Weight of the soil plus W water. So we have this volumetric ratios. We have three volumetric ratios. We have the void ratio, we have the void ratio, the porosity, and the degree of saturation S. So example of void ratio given decimal is 0.65. This is just an example. So the void ratio is actually the ratio of the volume of voids divided by the ratio of the volume of the voids to the volume of solids. No? And the volume of the voids is actually, this is V sub W plus V sub A. No? Void in the water and void in the air. And the porosity is given in percent, say 100% or 65%. Now this is just an example. And this porosity is actually equal to the volume of voids divided by the total volume of the soil sample, or V sub T. You can also express the porosity equal to um, the void ratio divided by 1 plus E. And the degree of saturation, also given in percent, say 100% or 65%, is equal to the total volume of voids contains water, that is V sub W, divided by the total volume of voids times 100%. So this is very important, no? Very useful in the computation of the in solving problems in the geotechnical engineering problems. So we have this weight relationship. We have this concept now. We have the water content also in percent. That is the mass equal to the mass of the water divided by the mass of soil solids times 100%. So for some organic soils, the water content is greater than 100% up to 500%. No? And for quick clays is greater than 100%. These quick clays, if you happen to watch a movie, there is also quicksands, di ba? Ang tendency sa quicksands ato is it will pull person, no, kanang maglisod na kaog balik because of its properties. Also, this quick clays, almost the same concept with the quicksand, no? The water content is greater than 100%. For the density of water, slightly varied with temperatures, the density of water is in terms of gram per cubic centimeter, that is 1, and for kilogram per meter cube, that is 1,000, or equal to 1 megagram per cubic meter. And we have also these densities, no, of soil. We have the dry density, which is equal to the mass of soil solids, that is M sub S, over the total volume of soil sample, V sub T. This is for dry density. For the moist density, or the wet or moist, no, density, that is the degree of saturation. It is within the range 0% to 100%, meaning that is unsaturated, no, not fully saturated, no. So the formula for the wet or moist density is equal to the mass of soil sample, that is M sub S plus M sub W, no. So that is soil solids plus mass of water divided by the total volume of soil sample, that is V sub T. For saturated density, saturated density meaning the degree of saturation is equal, clearly equal to 100%, and your air void is 0. So that the air, the void caused by the air is 0. So the saturated density is equal to the mass of soil solids plus water over the total volume of soil sample. Yes, almost the same formula with the unsaturated, but the difference is that the degree of saturation of saturated density is 100%. But when we talk about wet or moist density, the degree of saturation is within the range, below 100%. For the submerged density, this is the buoyant density, and this is equal to the saturated minus the density, saturated density minus the density of water. This is the submerged density. Uh, to understand density and unit weight, mass is a measure of a body's inertia or its quantity of matter. And mass is not changeable. It's not changed at different places. No? Weight is force, the force of the gravity acting on a body. So the value is different at various places, which is equal to, the concept of this one is Newton's second law, where the force equal to mass times the acceleration due to gravity. So the weight actually, this will change depending on the acceleration to gravity of the satellite or of the planet. So if you are in the moon, so that is 1/6 of the acceleration gravity of the Earth. So your weight is will change, but your mass remains the same. The unit weight is frequently used than the density. Example in calculating the overburden pressure. We have this density, mass. Density is equal to mass over volume, and the unit weight is the weight over volume, or that is equal to mass times acceleration due to gravity over volume. And yes, and the unit weight density times acceleration due to gravity is equal to 9.81. This is 9.81 uh, meter per second squared, and so that the water in terms of um, times the density of the water is 1 gram, or in kilograms, so will result to the unit weight of the water that is equal to 9.81 kilonewton per cubic meter. And this G sub S, this is the specific gravity. This is equal to the density of soil divided by density of water. So in terms of unit weight, that is unit weight of soil divided by unit weight of the water. This is relations among the unit weight, void ratio, moisture content, and specific gravity. So this is the phases, of the three soil element. We have this weight, or the total weight, and we have the weight of kaya siya maklaro na, this is actually the weight of this soil or soil solid equal to the specific gravity times the unit weight of the water. And this is the weight of the water equal to the moisture content small w times the specific gravity G sub s times the unit weight of the water. And this one, this solid, volume to solid is actually equal to 1.0, and the volume the water is equal to the moisture content times the specific gravity. And the volume of the voids, no, that is the air and water, this is W, I mean V sub B is E, so that the total volume, no, is equal to V sub T equal to 1 plus E. This one, no, this one, 1 plus E. So we have to remember this relationships, no, among unit weight, weight ratio, moisture content, and specific gravity. So the weight of the soil solids and water can be, so the weight of the soil solids is actually equal to specific gravity times the unit weight of water. So that the the weight of the water is equal to moisture content times weight of the soil solids. This is not minus, this is equal, no? This is equal, this one. This is actually equal, not minus. So that if you try to substitute this one to here, Nisha, this will become equal to this formula. The moisture content times the specific gravity of the soil solids times the unit weight of the water. No? Okay. This is the same uh, as earlier, the phases, no, of the soil element. Then we can also have this relationship among unit weight, porosity, and moisture content. So in terms of moisture content, the weight of the soil solids is equal to the specific gravity times unit weight of water times 1 minus porosity, or N. And the weight of the water is equal to the moisture content times the specific gravity times the unit weight of water quantity 1 minus N, or the porosity. And yeah, in terms of porosity, this volume of soil solids is equal to 1 minus N, and the volume of voids, no, that composed of air and water is equal to, this is V sub B equal to N, and the total volume is equal to 1. That is in terms of porosity. Uh, the the total volume of the soil element when it is saturated is equal to 1. We have this, okay, average specific gravity values. For example, we have for soil particles larger than 2 millimeter, the weight is W sub 1 and the volume is V sub 1. For soil particles smaller than 2 millimeter, the weight is W sub 2 and the volume is V sub 2. So we have to determine the average specific gravity values. So we have this, you have to add, no, the two unit weights and the two volumes, no, or we can express this one, 1 divided by V sub 2 plus V sub 2 over W sub 1 plus W sub 2. Or from here, we can also express this one as like this. This one, no? V sub 1 over W sub 1 plus W sub 2 plus V sub 2 over W sub 1 plus W sub 2. And is actually the same with this one, no? Actually, mahimo na siya o V sub 1 over W sub 1 plus W sub 2 plus V sub 2 over the property of addition, no? V sub 2. Or from here, you can also express this as this one. This one. So, niya siya gibutang nga W1 in the numerator and W1 in the denominator. So that when you try to cancel this one, mahimo siya the same with this. No, the same with W2, no, nasa numerator and in the denominator. So that the average specific gravity is equal to 1 over this P sub 1. Excuse me. And this P is the weight fraction. You know? Yes. This one, this is the weight fraction. This is the weight fraction. This one. So actually this P1. And as the specific gravity is actually equal to weight over the volume. So that you should make it as reciprocal of this V1 over W1, no? Unang 1 over specific gravity 1 plus P sub 2 or the weight fraction P sub 2 times 1 over G sub 2 or the reciprocal of this ratio, no? So, for the engineering applications, we have different types of soil, no? And it's their void ratios. We have the maximum void ratio and minimum void ratio and the porosities and the dry unit weight, no? For example, we have these silty sand and gravel. The maximum void ratio is 0.85, the minimum is 0.14, maximum porosity is 46, no? Actually, for the why there is this maximum minimum, because we have this composition of soil particles. Like for example, this one, a simple cubic, the porosity is 0.91, no? But if you try to make this composition or arrangement of particles into cubic tetrahedral, the porosity is smaller, 0.65, because comparing with a simple cubic arrangement, there is actually a big voids, no? That's why the void ratio is bigger, because the void ratio is actually equal to the ratio of the volume of voids divided by voids composed of air and water, diba? Divided by the volume of solids. So, mo na siyang mas gamay ang 0.65 na cubic tetrahedral, because if try to look at the void gap, the voids, it's actually smaller compared with this na void diri, no? So, the volume change tendency, and there is change also of strength. So there is a link, the strength of rock joint, and also shear strength, that is equal to nominal shear strength times tangent of uh, the angles phi plus I. Later, you will learn this one in the technical engineering 2. Continuation of the engineering implications. The hydraulic conductivity. So the which packing, or SC, or that is simple cubic or cubic tetrahedral. No? Which packing, the simple cubic or cubic tetrahedral, has higher hydraulic conductivity? So meaning of hydraulic conductivity is this one. The meaning of this one is asa ang mas dali mo flow ang water. Arrangement, simple cubic or cubic tetrahedral. Siyempre, because of dako nga void man siya, kani ang mas dako og the SC, no? The fluid water can flow more easily through the soil with higher hydraulic conductivity. So actually, the SC, no, or simple cubic, has the higher hydraulic conductivity because of bigger voids. So this one, this represent this one, no, because of this void ani. So lusot lang siya. The finer particle cannot pass through the void. This is SC, the simple cubic and the cubic tetrahedral arrangement of particles. So, it is like there is a filter, no, in the cubic tetrahedral, which is of lesser void ratio. For completely dry soil, the degree of saturation is equal to 0%. For completely saturated soil, the degree of saturation is 100%. For unsaturated soil, or that is partially saturated soil, the degree of saturation is within this range, no, 0% to 100%. So the degree of saturation is actually equal to the total volume of voids contains water divided by total volume of voids times 100%. So this engineering applications is for the demonstration of the effects of capillary forces. No? Later, for our computation in the pressure, no, and for the engineering implications is for the slope stability and underground excavation. This will be tackled in the later part of the geotechnical engineering, or I think this is can be tackled in geotechnical engineering 2, soil mechanics 2. For the continuation of the engineering applications, we have this 80% of landslides are due to erosion and loss in suction um, in Hong Kong. No? The slope stability is significantly affected by the surface water. So we have this representation of the rainfall. Then that rainfall will go into the surface. No, that will be called surface water, and yeah, it will infiltrate. Now there is infiltration. We have this. There is infiltration or direct ingress, and there is also erosion. So if you try to look at this chart, you know, this infiltration will have positive pore water pressure built up from deep subsurface water and shallow subsurface water. Meaning, the deep subsurface water, as you can see, there is less than 1%. Now, this is the the percent that it will affect the slope stability, or will become landslide. And we have the shallow subsurface water is approximately 20%, no? So meaning 20% that it will cause erosion or landslide. And as you can see, there is this erosion and loss in suction is actually 80%. This means that it has bigger, no, something to do with the erosion. This figure, we have the rainfall, then surface runoff, then that some will infiltrate into the deep subsurface and some will into the shallow subsurface water, but most of the surface water will the shallow, no, will be the cause of the erosion. We have also this term, the submerged unit weight, that is equal to this is denoted as gamma prime, no, equal to the saturated unit weight minus the unit weight of the water. So there is actually a derivation, but the important thing is this one, oh, this one. This follows the Archimedes principle, which is equal to the equal, which means the buoyant force on a body immersed in a fluid is equal to the weight of the fluid displaced by that object. All right. Um, Continuation, for fine-grained soils, water plays a critical role to their engineering properties. For example, the quick clay usually has a water content greater than 100% and a card house structure. It will behave like a viscous fluid after it is fully disturbed. Yes, especially fine-grained soils. So if there is more water content or greater than 100%, no, the quick clay will become like a viscous fluid. Then we have other relationships, no? We have the specific gravity. This is discussed earlier, no? This is density of soil divided by density of water, or we have the unit weight of soil divided by the unit weight of the water. And also we have this number two relation, this density of water times the saturated unit weight, I mean degree of saturation times the void ratio equal to the water content or moisture content times the density of the soil. Or if try to divide this one by this one, this will become this, no? The proof is this, no? Why this degree of saturation times void ratio is equal to the water content times the specific gravity. We have to understand the proof. The water content is equal to the volume of water divided by the volume of voids times Yes, the water content is actually this one. The volume of yes is also equal to this one. No? This S sub degree of saturation times void ratio is also equal to, alright, the degree of saturation times void ratio. The degree of saturation is actually equal to the volume of water divided by the volume of the voids, and this void ratio is actually equal to the volume of the voids divided by the volume of solid. So this will cancel, and the remain will have the ratio of volume of water divided by the volume of solids. And this WGS, or the water content, is actually equal to the mass of the water divided by mass of soil solids. And the specific gravity is equal to the density of soil divided by density of water. No? And yeah, canning densities of soil is equal to the mass of soil divided by mass of volume of soil, and the density of water is equal to the mass of water divided by the volume of water, so that this will cancel, and this one, no, so the uh, remain relationship is equal to this volume, which is the same with this one. That is why this SE is equal to WGS. We have the typical values of specific gravity of different minerals. No? For example, the quartz is equal to 2.65. For the specific gravity, it has no unit. Solution of phase problems. So if there are computations or problems, we just have to remember the following simple rules from Holtz and Kovacs in 1981. Number one is remember the basic definitions of moisture content, the void ratio, the density of soil, the degree of saturation, etc. And draw a phase diagram. Katong diagram of the soil below, then we have the water and the air above. Then assume either the volume of the soil is equal to 1 or the total volume is equal to 1 if not given, and often use this one. The degree of saturation times the void ratio is equal to the moisture content times the specific gravity of soil. Alright, we have this sample problem. No? The unit weight of the soil is equal to 14.9 kilonewton meter cube per meter cube, with a moisture content of 17% and degree of saturation S is 60%. Determine the void ratio. This is E. The saturated unit weight, this is gamma sat. And the specific gravity of soil solids, or this is the G sub S. Yes, we are given with the unit weight of soil that is equal to, this is the moist unit weight, 14.9 kilonewton per meter cube, no? And we are required to determine the void ratio. We have the moisture content equal to 70%, and the degree of saturation equal to 60%. So the moist unit weight is actually equal to the um, mass of or weight of the soil plus weight of the water divided by the total volume, no? And the mass of the weight of the soil is equal to, try to remember this, kung ganina ang katong face, this one. The mass of the soil is actually equal to specific gravity times the unit weight of the water, and the mass of the water is equal to moisture content times specific gravity times unit weight of the water. So later example, this example can be expressed as specific gravity this is specific gravity times unit weight of water plus, for this one, weight of soil plus moisture content specific gravity times unit weight of water divided by the total volume. In this case, the total volume is actually equal to 1 plus E, di ba? This one. Total volume is equal to 1 plus E. One plus E, or void ratio. But remember this equation, the specific degree of saturation, SE, degree of saturation times void ratio is equal to moisture content times specific gravity, di ba? The moisture unit weight of soil is actually given equal to 14.9 equal to specific gravity, which is unknown, but we can express, okay, let's leave as G sub S times unit weight of water, that is 9.81, plus moisture content, which is given 0.17 times G sub S unknown times unit weight of water, which is 9.81 over 1 plus E, diba? We are required to determine the E. This one is the first equation, but we can also have this second equation in terms of this formula, that is equal to degree of saturation is 60%, so 0.6 times E, which is unknown, equal to unit weight 0.17 times the G sub S is unknown. So we have two equations. This is equation 2. We have two equations, 1 and 2, and two unknowns. This is specific gravity and the void ratio. No? If we try to solve this one, these two equations, E is equal to 0.582. Actually, this is the same solution with this one, but this solution uses this Young's ang G sub S convert niya into SE over W, no? Pero you can also follow also this one so that only one is the unknown, the void ratio E. And for the saturated unit weight, alright, the saturated unit weight for letter B the formula is equal to gamma sat equal to specific gravity plus E times unit weight of water over 1 plus E. And in here, the G sub S is expressed as SE over W. No? Kani siya. Actually, parihara ni siya ani. So, then substitute the values. G sub S is already unknown in this equation. I mean, is known in these equations, di ba? Because you will get the void ratio and the specific gravity. So, makuha naman specific gravity ni mo dire, then substitute dire. Also, the E is already unknown in here, di ba? And the unit weight of water is 9.81. So that the gamma sat is, or the saturated unit weight is equal to 16.35 kilonewton per cubic meter. And the specific gravity of soil solids is can be expressed as this one. But in this equation, actually, makuha na nimo ang specific gravity G sub S. So that the answer is 2.05. Try to, again, solve this problem, and compare, no? If the answers are correct. Then we'll move to the second problem.